Let us look at proposition number 29 of book 6 of Euclid's Elements. The proposition says to apply a parallelogram equal to a given rectilinear figure to a given straight line, but exceeding it by a parallelogram similar to a given one. Okay, let's see how we go about doing this. First of all, we will take the midpoint of AB, and on this we will construct a parallelogram similar to D. Yes, we know how to do that. Let's mark the points, the relevant points. Now we have, let's actually convert this figure into a parallelogram. Again, we know how to do that. Yes. So let's do this. Let's join these 2 points to form a triangle. Let's join these 2 points to form a triangle. So basically we convert this rectilinear figure into a set of triangles. Take the midpoint of the base of one of the triangles, and on that, on half of this, we construct a parallelogram whose area is equal to this triangle's area. Okay? Similarly, we take the midpoint of this triangle and we construct a parallelogram on half of the base of the triangle. Again, we take the midpoint of the third triangle and we construct a parallelogram. Once we have done this, we take 2 points, join them. This would be equal to EB because we want the parallelogram to be able to sit on EB. Okay. So let's convert this, or rather construct the parallelograms on this equal to these parallelograms. So this is a parallelogram which is equal to this parallelogram. Similarly, we create another parallelogram on top of that which is equal to this parallelogram. And then finally, we construct one more parallelogram equal to the third parallelogram, which is in turn equal to the third triangle. Now, this entire parallelogram is equal to this entire rectilinear figure. It is equiangular to the given parallelogram, but its sides are not in proportion. So to make this similar to D, we again create the parallelograms along D. Okay? Let's see. So this parallelogram is equal to this parallelogram, and along with that, further on, we create a parallelogram which is equal to this parallelogram. So now we have D and we have this. Now what does this represent? This represents this parallelogram. If I move this and position it, you will notice that this is equal to C. The area of all these three is equal to the area of C, and this is FB, a parallelogram which is similar to D. So which means that these two put together is nothing but FB plus C. Okay? This is FB, this is C. So we have formed a parallelogram which represents FB plus C. Now we figure out the third proportion. This is to something is equal to that something is to this. I've done it, below. So I'll just present the parallelogram. We mark these points. So GH is equal to FB plus C, and it is similar to D. Now, how do I know that it is actually similar? if I move this, you will notice that B appears on the diameter of GH. What is the next step? Now, instead of just moving it here, let's actually construct it, this parallelogram on this parallelogram. Let's do that. Now, to construct that, I extend FL to M so that FLM is equal to KH and FEN is equal to KG. And now I join these points. I join the remaining points. So you notice B is falling on the diameter. Okay. Now what we have achieved by doing all this is constructed a parallelogram which is in red, which is on AB, whose area is equal to the given rectilinear figure C, yes, and which is in excess of a parallelogram similar to D, which is in excess of AB by a parallelogram which is similar to D. So this part is similar to D, and that is the excess part. So we have achieved our goal. But let's prove it step by step. We know parallelogram FB, this one, the violet one. Parallelogram FB is similar to parallelogram D. We know parallelogram GH is equal to parallelogram FB plus C. Parallelogram GH is similar to parallelogram D, which means parallelogram GH is similar to parallelogram FB, and parallelogram MN is equal to parallelogram GH. So that means all these parallelograms are similar to each other. Parallelogram MN, GH, D, and FB, they are all similar to each other. EBL, this is our gnomon. Gnomon EBL is equal to figure C. Since GH is FB plus C and MN is FB plus gnomon. So FB, if we cancel it out, we are left with gnomon is equal to C. This parallelogram, parallelogram LP, is equal to parallelogram EQ. Why? Because they are complementary parallelograms. And we know parallelogram AN is equal to NB. So these two are equal because E is the midpoint of AB. So these two are equal, these two are equal. So we can say parallelogram AO, this entire red parallelogram, is equal to AN plus EO. Since AN is equal to LP, we can do the substitution and say parallelogram AO is equal to parallelogram LP plus parallelogram EO. Now, LP plus EO, LP plus EO is nothing but the gnomon. And we have already seen that the gnomon is equal to figure C. So we can say parallelogram AO is equal to figure C. And it exceeds AB by a parallelogram similar to D. So that was proposition number 29 of book 6 of Euclid's Elements. Again, you need to be very careful while constructing it so that you can do this. So you move this around, change the figure, automatically everything else also changes. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and in case you feel somebody else can also benefit from it, please do share. That's it for now.